Is reality a mathematical structure? It's a strange question. Maybe it even sounds a bit wild, but it's a question more and more smart people are asking. They're not just asking if math describes reality well. They're asking if math is reality. If the universe at its most basic level is made of mathematical patterns and relationships. Think about that for a second. We usually see math as a tool, like a language we use to talk about the world. We count things, we measure things, we make equations to predict how things will move or react. But what if math isn't just a language for reality? What if it's the very stuff reality is made of? What if the universe isn't described by math, but is math? It's a big idea, a really big one. Let's unpack this a bit. When we talk about reality being a mathematical structure, we're not just talking about numbers. We're not saying everything is a 3 or a 7. It's more about abstract patterns, about relationships, about logic. Think of it like this: a circle isn't just a number. It's a geometric shape, it has properties. Every point on its edge is the same distance from its center. That's a mathematical idea. A perfect circle doesn't really exist in the messy real world. As we draw circles, but they're always a bit off. Yet the idea of a perfect circle exists. It's a mathematical structure, and we see circular things everywhere, imperfect as they are. From planets orbiting stars to ripples in a pond. So when we say reality might be a mathematical structure, we mean it's built from these kinds of fundamental abstract patterns and rules. Like the rules of geometry or the laws of physics, they aren't just descriptions of what happens. They are what happens. Now, where does this idea come from? A lot of it comes from physics. When you dig deep into how the universe works, you always find math. Always. It's not just a little bit of math, it's math all the way down. Think about Isaac Newton. He figured out how gravity works. He saw an apple fall. He saw the moon orbit the Earth. And he came up with a simple equation, FTGMMR2. That equation describes how gravity pulls things together. It's incredibly powerful. It works for apples, for planets, for galaxies. It's a mathematical relationship. It doesn't just describe the force it seems to be the force, in a way. The universe obeys that equation. Then there's James Clerk Maxwell. He looked at electricity and magnetism. He saw they were connected. And he wrote down a set of equations. These equations show that light is an electromagnetic wave. Think about that. Light, something we see every day, is described perfectly by these mathematical patterns. These equations didn't just explain what people saw. They also predicted new things, like radio waves. And later, those predictions came true. The math led us to discover things we hadn't seen yet. Move on to Albert Einstein. His theories of relativity completely changed how we see space and time. And again, it's all math, EMC2, that's a tiny equation, but it describes something huge, how energy and mass are related. It tells us that mass can be converted into energy and vice versa. It's the basis of nuclear power, for example. And his general relativity, that's about the geometry of space-time. It says gravity isn't a force pulling things. It's the bending of space and time by mass and energy. So planets orbit the sun not because the sun pulls them, but because the sun warps the space-time around it, and planets just follow the curves in that warped space. This is a deeply mathematical idea. It's about shapes and curvature and geometry. And then there's quantum mechanics. This is the math that describes the super tiny world of atoms and particles. It's weird math that's about probabilities, about things existing in multiple states at once until we observe them. It uses wave functions. It shows that energy isn't continuous. It comes in discrete packets or quanta. These are all deeply mathematical concepts. They don't have good everyday analogies. You can't really imagine what an electron looks like, but the math describes its behavior perfectly. And these mathematical descriptions allow us to build things like lasers, transistors, and computers. The point is, time and time again, when we look deeper into the universe, we don't just find a little math. We find that math is the very language the universe speaks. And it's not just a language we invent to understand it. It seems to be the language of it. The universe doesn't seem to just allow mathematical descriptions. It seems to be a mathematical description. It has these fundamental constants like the speed of light or Planck's constant, which are just numbers. Fixed numbers that are part of the fabric of everything. So we have a puzzle here. Is math just a tool we use to understand reality? Or is it the fundamental reality itself? Most people naturally think math is a tool. It's like a map. A map helps you understand a city. It tells you where the streets are, where the buildings are, but the map isn't the city. The city is a real physical place. It's made of bricks and concrete and people. The map is just a representation. This view says that reality is something else entirely. It's something physical, something stuff-like. And math is just our best way of describing that stuff. We use math to build models of the universe, and these models are really good. They're so good, in fact, that they let us predict things and build technology. But, under this view, the math isn't the thing itself. It's just how our minds categorize and understand the thing. Reality exists independently of the math. If humans vanished, reality would still be there, doing its thing, but no one would be writing equations about it. But then there's the other, more radical idea, the one we're really talking about here. This idea says the map is the territory, or to be more precise, the universe is the mathematical structure. It says that reality isn't just described by math, it is a mathematical structure. This means that if you strip away everything else, all the matter, all the energy, what you're left with are these abstract mathematical relationships and patterns. These are the most fundamental things. The universe is a giant, incredibly complex mathematical equation or system. Why does this distinction matter? Well, if math is just a tool, then there could be aspects of reality that are not mathematical at all. Things that our mathematical tools simply can't grasp. Reality might be fundamentally messy, unpredictable, and non-logical in ways we can't capture with equations. We might be missing huge parts of it. But if reality is a mathematical structure, then everything, literally everything, ultimately boils down to these abstract patterns and relationships. There's nothing behind the math. The math is it. It means there's an inherent order, a deep logic to everything. This idea has some pretty deep philosophical roots. It connects to something called Platonism. The ancient Greek philosopher Plato believed that there was a realm of perfect forms or ideas. Things like a perfect circle, or perfect beauty, or perfect justice. These forms existed independently of our minds and independently of the imperfect examples we see in the physical world. Our physical world was just a shadow or an imperfect copy of these perfect forms. In a similar way, mathematical Platonism suggests that mathematical objects and structures exist independently of us. They aren't invented by humans, they are discovered. The number 3, or the concept of a triangle, or the laws of geometry. These aren't just human ideas. They have an existence of their own, whether humans are around or not. And if that's true, then it's a very small step to say that the universe itself might be one of these existing mathematical structures. We're just living inside one of them. This brings us to a famous observation by physicist Eugene Wigner, who talked about the unreasonable effectiveness of mathematics in the natural sciences. He was amazed by how incredibly good math is at describing the universe. It's almost spooky. Why should a bunch of abstract concepts and symbols cooked up in our heads be so perfectly aligned with how the physical world works? Is it just a coincidence, or does it point to something deeper? If reality is a mathematical structure, then the effectiveness of math isn't unreasonable at all. It's perfectly reasonable. Math works because the universe is math. But what about the challenges to this idea? And there are big ones. The biggest one for most people is consciousness and emotions and subjective experience. Can a mathematical structure truly account for what it feels like to see the color red? Or to fall in love, or to feel pain. These are called qualia, the raw, subjective qualities of our experiences. It's hard to imagine how an equation or a geometric pattern could feel like anything. If reality is purely mathematical, how do we fit our inner world into that picture? Some suggest that consciousness might just be an emergent property of incredibly complex mathematical structures, like the neural networks in our brains. They say that if you have enough complexity, enough information processing, consciousness just arises from it. Like how a hurricane emerges from certain weather patterns, it's not that a hurricane is a single mathematical entity, but its behavior is described by a huge amount of math. Maybe consciousness is like that. Others suggest that maybe our understanding of mathematical structure is too limited. We think of math as numbers and equations. But perhaps there are vastly more complex and abstract mathematical structures we haven't even conceived of yet. Structures that could encompass subjective experience. It's a huge leap, though. And some argue that consciousness might be the observer, and the universe is the observed mathematical structure. So, consciousness isn't part of the mathematical structure, but the entity that perceives it. But then, where does consciousness come from? It still needs an explanation. Another challenge is the why anything at all question. Even if reality is math, why this specific math? Why this particular universe with its specific laws and constants? Why not some other mathematical structure? The idea might explain how things work, but maybe not why there's anything working at all. This leads us to different flavors of the reality is math idea. One of the most prominent comes from a physicist named Max Tegmark. He proposes something called the mathematical universe hypothesis MUH. It's pretty wild. And Tegmark suggests that all mathematically consistent structures exist, not just our universe, but every possible universe that can be described by math. Our universe is just one of these structures, and we're conscious substructures within it. It's a very extreme, very bold claim. It means there are an infinite number of universes out there, each corresponding to a different mathematical structure. If this were true, it would explain why our universe's laws seem so fine-tuned for life. It's not that our universe is special, it's just that we are in one of the universes that allows for life and consciousness to observe it. Other mathematical structures might be just as real, but they don't contain observers like us. Another related idea connects to information theory. This view suggests that reality is fundamentally information. And information, at its core, is deeply tied to math. Bits of information, logical operations, processing, these are all mathematical concepts. Think of a computer. It processes information using binary code, which is just 0 and 1. A very simple mathematical system. If the universe is fundamentally information, then it's essentially a vast, complex mathematical computation. This gives rise to the computational universe idea. This is the thought that the universe itself might be a giant computer, simulating itself. Math is the underlying code, the algorithm, the operating system. When we observe particles and forces, we're seeing the output of this cosmic computation. It's like we're characters in a video game, and the rules of our world are the mathematical code of the game. What are the implications if this idea is true, if reality really is a mathematical structure? First, it profoundly changes our understanding of existence. It suggests that the most fundamental things aren't stuff in the way we usually think about it, not tiny billiard balls or waves. Instead, the most fundamental things are abstract patterns, relationships, and logical rules. It means existence isn't about being something material, but about being a particular configuration within a mathematical framework. Second, it changes our place in the cosmos. If we are patterns within a vast mathematical system, are we just complex equations? Are our thoughts and feelings just emergent properties of these patterns? It's a deeply humbling and perhaps unsettling thought. It gives us a sense of being part of something grander and more abstract than we ever imagined. Third, it hints at the limits of our understanding. Can we ever fully grasp the master equation, or the complete mathematical structure of the universe? Our brains are themselves physical structures, part of this proposed mathematical reality. Can a part fully comprehend the whole? It's like a computer program trying to understand the operating system it runs on. It can understand aspects, but maybe not its own fundamental nature or its full scope. Fourth, it gives a powerful boost to the scientific search for a theory of everything. This is the goal in physics, to find a single, unified theory that explains all fundamental forces and particles. This search inherently assumes a deep mathematical unity to the universe. If reality is a mathematical structure, then such a theory must exist. It's just a matter of finding the right set of equations, the right mathematical framework that describes everything. And finally, it speaks to beauty and order. If the universe is a mathematical structure, it implies a deep, inherent order to everything. Not just a random collection of events, but a logical, structured system. There's a profound beauty in that. Mathematicians often talk about the beauty of an elegant proof or a simple, powerful equation. If the universe is such a structure, then there's an inherent elegance to existence itself. So, where does that leave us? This idea that reality as a mathematical structure isn't a proven fact. It's a hypothesis, a very powerful, very thought-provoking hypothesis that many leading physicists and cosmologists are seriously considering. It's a framework for thinking about the universe that explains many of the baffling aspects of physics, like the unreasonable effectiveness of math. It forces us to rethink what real even means. Is a number real? Is a concept like symmetry real? If so, then perhaps the universe is built from these kinds of realities. It leaves us with a sense of wonder. A wonder not just about the vastness of space or the complexity of life, but about the very nature of being. About the deep abstract patterns that might underlie everything we see, feel, and touch. We use math to grasp our world, and maybe, just maybe, that's because our world is math.